Somewhere in our solar system, there's a planet whose rings are so massive, if you laid them flat, they'd stretch wider than the distance between Earth and the Moon. Now imagine those rings disappearing in an instant, torn apart and swallowed by something with no surface, no light, and no way back. What if Saturn collapsed into a black hole? What would actually happen to its rings, and would anyone on Earth, 93 million miles away, even notice? Let's start with what a black hole actually is, because most people get this wrong. A black hole isn't some cosmic vacuum cleaner that sucks in everything nearby. It's simply an enormous amount of mass compressed into an incredibly small space. And here's the part that surprises people. If Saturn somehow collapsed into a black hole without losing any of its mass, its gravity on everything around it would stay exactly the same. Not stronger. Not weaker. The same. Gravity depends on mass, not size. So Titan, Enceladus, and every other moon currently orbiting Saturn would keep orbiting a black hole in Saturn's place, at exactly the same distance, completely unaffected by the transformation itself. But the rings are a different story entirely. Saturn's rings exist because they're made of countless icy chunks and dust particles, held in place by the delicate balance between Saturn's gravity and their own orbital speed. Remove the planet's actual physical surface, and that balance doesn't just disappear, it changes completely. A black hole this size would have an event horizon only a few centimeters wide, smaller than a grape. Compared to the vastness of the rings, this new black hole would be an almost invisible point in the center of a system that no longer has anything to visually orbit. Without Saturn's solid body, the intersections of the rings would begin spiraling inward almost immediately, drawn toward the black hole's crushing gravity at its very center. As ring particles get closer, tidal forces would start ripping them apart piece by piece, a process called spaghettification, where the difference in gravitational pull between the near side and far side of an object stretches it into long, thin streams before it's consumed entirely. The rings wouldn't be swallowed all at once. They'd be shredded gradually, funneled into a bright, spinning disk of superheated debris circling the black hole, glowing intensely as friction and compression heat the material to extreme temperatures. This is actually what real black holes look like up close. Not the empty darkness people imagine, but a violet, glowing ring of infalling material called an accretion disk, blazing with light generated by matter being torn apart. Saturn's rings, in this scenario, would become exactly that. A brilliant, chaotic halo of destruction, visible even from other parts of the solar system, marking the final moments of billions of years of icy debris. So what about Earth? If Saturn's rings are being consumed by a black hole roughly 900 million kilometers away, what would we actually experience down here? Almost nothing. And that's the twist worth sitting with. To put the distance in perspective, light from Saturn takes over an hour to reach Earth, meaning we'd be watching this entire transformation unfold on a delay, seeing the black hole and its glowing ring of debris only after the fact, like light from a star that already burned out. Because Saturn's gravitational influence on Earth today is already extremely weak given that distance, converting Saturn into a black hole of the exact same mass wouldn't meaningfully change Earth's orbit, our seasons, or anything else about daily life on our planet. No shockwave. No gravitational disturbance strong enough to notice. No visible change to our night sky beyond, perhaps, a very faint new point of light where Saturn used to reflect sunlight, now replaced by the glow of its own dying rings. Even the radiation produced by the accretion disk, intense as it would be up close, would arrive at Earth so diluted across 900 million kilometers of empty space that our atmosphere and magnetic field would handle it without any noticeable effect, the same way we're shielded from far more energetic events happening elsewhere in the galaxy every single day. The one exception worth mentioning is Saturn's moons, Titan and Enceladus, and the rest would continue orbiting normally, completely unaware, in a sense, that anything about their host had changed. Their orbits wouldn't destabilize, because as we covered earlier, the mass creating their gravity hasn't gone anywhere. They'd simply be orbiting a black hole instead of a gas giant, a genuinely strange fact when you sit with it. Life, if it existed on any of Saturn's icy moons, would go on completely undisturbed by an event that sounds, on the surface, like one of the most catastrophic things imaginable. In the end, this scenario reveals something counterintuitive about how gravity actually works. The most visually dramatic, seemingly apocalyptic transformation imaginable, a planet becoming a black hole and devouring its own rings, would barely register beyond Saturn's immediate neighborhood. Earth would keep spinning. Our seasons would stay the same. And 93 million miles away, we'd likely never even know it happened, unless we were pointing a telescope in exactly the right direction at exactly the right time. Sometimes the most dramatic events in the universe are the ones that matter the least to us, simply because of how far away, and how small, we really are.